Hello everyone. Can you guess the topic? What we are going to see about today? For example, I will tell you the example. For example, seating people around the table, seating arrangements, and finding out the rate of change of population and the spread of virus. Alternating series is nothing but it's of two version. First one is a odd one, and the another one is an even one. When an odd index terms are negative, for example, summation k equal to 1 to infinity minus 1 the whole power k into ak, which is if we expand with the summation, we get minus a1 plus a2 minus a3 plus a4 plus up to etc. In the even terms, we get it as summation k equal to 1 to infinity minus 1 the whole power k plus 1 into ak equal to, if we expand the term, we get it as a1 minus a2 plus a3 minus up to etc. This is said to be a negative indexed term, and the upper one is said to be an odd indexed terms. Alternating series test. How we find out the series in alternating series? Limit k tends to infinity, ak equal to 0 does not convergence of the series. If we expand the term, we get it as obviously 0 value. And an alternative series, first thing, it should be in convergent. If the limit is k tends to infinity, ak equal to 0, then sequence ak is a decreasing sequence. That is ak plus 1 less than or equal to ak for all k. Next, calculating the limit k tends to infinity ak value. If the limit is not equal to 0, then it is a divergent series. If the limit is equal to 0, then it is a convergent. Then verifying the sequence ak is a decreasing sequence. For example, summation k equal to 1 to infinity minus 1 the whole power k plus 1 into k by k square plus 1. If we expand the term, we get it as summation k equal to 1 to infinity minus 1 the whole power k divided by k value. Using L'Hopital's rule, in checking an L'Hopital's rule, for example, limit k tends to infinity ak, take an example as ak as minus 1 the whole power k plus 1 log k divided by k. When we expand the term, we will get it as limit k tends to infinity log n x divided by x, which is equal to limit x tends to infinity 1 by x divided by 1. If we differentiate the term log x, we get it as 1 by x. If we differentiate the term x, we get it as 1. When we apply the limit, we get it as 0. Then absolutely convergence. Absolutely convergence is nothing but an, if the summation ak is converges, then summation modulus of ak is also converges. Then it is said to be an absolute convergence. Consider a sequence summation ak where the general term varies in a sign. Plus sign and minus sign will get varying. The alternation of the series may or may not be a regular pattern. If an summation modulus of ak converges, so does summation ak also converges. That is said to be an absolute convergence. For example, summation k equal to 1 to infinity minus 1 the whole power k plus 1 divided by k power 3 by 2. Next one is conditional convergence. Conditional convergence is nothing but it is still possible that summation modulus of ak is diverges, then summation ak is still a convergence, then it is said to be a conditional convergence. It need not to be necessary in summation ak will be an divergent series if summation modulus of ak is divergence. It is said to be in conditional convergence. For example, summation k equal to 1 to infinity minus 1 the whole power k divided by k, and summation k equal to 1 to infinity 1 by k. This is an example for a conditional convergence. Next one is the ratio test. If the three conditions are satisfied, then it is said to be a ratio test. For example, summation ak ak must be not equal to 0 for k is greater than or equal to 0, and the limit k tends to infinity modulus of ak plus 1 divided by ak equal to 1, where L is a real value or infinity. If L is less than 1, then it is in summation ak is converges absolutely. If L is greater than 1 or L is an infinity, then the series is diverges. If L equal to 1, then the test is inconclusive. This is a ratio test. Example for ratio test means summation k equal to 1 to infinity minus 1 the whole power k plus 1 into 2 power 2k plus 1 divided by k factorial.